In this presentation, I am going to explain the new thing called power of the lens. Here I have drawn two lenses. One is called convex lens and another one is called concave lens. You know very well that the convex lens, it is able to converge the light rays. When the light rays, when they come from long distance, they are converged at a particular point. Here all the rays are converged. The distance between the principal focus and the optical center is, what is this? Focal length. Here look at the another diagram. In the case of concave lens, the rays, they travel from long distance. After incident on the lens, they are diverged in various directions. Finally, they appear to come from this point. So this one is called principal focus. In between the principal focus and optic center, that focal length can be measured. Here actually the rays are converged, but here the rays, they appear to come from this point. Whether it may be a convex lens or concave lens, in both the two cases, we are able to measure a new quantity called power of the lens. The term power, that is used by ophthalmologists, opticians, while manufacturing the lenses, whether it may be a concave lens or convex lens, they are manufacturing the lenses on the basis of the factor called power of the lens. Even while prescribing the spectacles, ophthalmologists, they used to prescribe the spectacles only on the basis of the eye defects, and they will mention the power of the convex lens or concave lens in their prescription. Okay, so the term power, how it can be calculated? First you have to learn what is the power of the lens. This is the factor that is related to either convex lens or concave lens. Here we are going to learn the basic definition of which one, that power of the lens. Look at that. First I have written the definition for convex lens. Later I will explain the definition of power of the lens for concave lens. Here the lens is able to converge the rays. That lens is having the ability to converge the rays. Different lenses with different focal length, they are having different power. Are you clear? Look at the definition. The ability to converge. Who will converge? Convex lens alone will converge the light rays. So whose ability? Lens ability is called, what is this? Power of convex lens. Again we'll read, the ability to converge. Who is able to converge? Convex lens is able to converge, is called power of the convex lens. That lens is having the ability to converge the rays, no, that ability is called power of the lens. Otherwise, the same definition that could be told in some other form. What is this? Degree of convergence. That ability is otherwise called as, what is this? Degree of convergence. Who is converged? Light rays are converged. The degree of convergence of light rays is called power of the convex lens. So there are two definitions which are written especially for convex lenses. Are you clear? Now let's come to the second category of lens. What is this? Concave lens. Here, instead of converging, there we have to use a term called diverge. Instead of convergence, we have to use a term called divergence. Are you clear? Here, that concave lens is able to diverge the light rays. That's why we call it as the ability of the divergence, or we can say it as the ability to diverge. Who is able to diverge? Concave lens is able to diverge the rays. That ability to diverge the light rays is called, what is this? Power of concave lens. Otherwise we can call it as the degree of divergence of light rays is called power of concave lens. But in the textbook definition, both are combined as a single statement. How the statement will be? The ability to converge or diverge, ability to converge or diverge the light rays by the lens is called power of the lens. That is the general definition. The second definition that can be told as a common thing, common statement, the degree of convergence or divergence of the light rays by the lens is called power of the lens. So the lens is either it is capable of converging the light rays or capable of diverging the light rays. No, that ability is called power of the lens. Okay, now mathematically how power can be calculated? That is the next question. That power of the lens, that depends on the focal length. Are you clear? By using the value of focal length, the power of convex lens as well as power of the concave lens, both can be measured. Are you clear? Now, in the next topic, I am going to teach how the power of the lens can be calculated. Okay. Now we are going to learn how the power can be calculated. That power of the lens is purely determined by the focal length of the lens. The formula is power of the lens is nothing but reciprocal of the focal length. Understand? Focal length to be measured, that is to be reciprocated. 1 by focal length, that gives you the power of the lens. Here I have given two typical values. Let's calculate the power of the given convex lens. What is the formula? Here that value that is given in terms of centimeter. If the value, if it is given in terms of centimeter, the formula can be slightly altered. So if it is given in terms of meter, if the focal length is given in terms of meter, this formula can be used. Are you clear? If the value, centimeter value, if the focal length value, if it is given in terms of centimeter, this formula can be used. 100 by focal length. Are you clear? In centimeter can be used. Understood? Now I will calculate 100 divided by the focal length in centimeter to be substituted here. Understood? So after that, cancel both, you will get 10. Are you clear? This 10 is nothing but power of the lens. That power of the lens to be written in terms of the unit called diopter. Are you clear? D. Simply it can be written as D. D is nothing but, what is this? Diopter. Diopter is a unit of power of the lens. Are you clear? Since the lens is convex lens, the value of power must be taken as positive. Always the power of the lens must be taken as positive in the case of which lens? Convex lens. Don't forget, in the case of convex lens, the power of the lens is positive. Are you clear? The unit of power of the lens is diopter. It can be simply written as D. Are you clear? The unit is D. Understood? What is the formula to calculate the power of the lens? 1 by focal length. Are you clear? If it is given in centimeter, you can use this formula. If it is given in meter, you have to use this formula. Understood? Now we are going to calculate the power of the concave lens. How to calculate the power of the concave lens? No difference, same formula to be used. The only thing is sign to be altered, sign to be changed. Here also the focal length of the concave lens is 10 centimeter. So substitute the value 100 divided by f must be substituted. Here the f is given in terms of centimeter. Understood? So power to be calculated. Here in the formula minus sign must be written. Why? Because it is diverging lens. In the case of concave lens, negative symbol must be written. Substitute the value 100 divided by 10 centimeter. Substitute. Clear? You will get the value. The final answer must be written as minus 10 diopter. As soon as you see the symbol minus, it shows that the nature of the lens is concave. That negative symbol itself shows that the power of the lens is negative, means it shows that the nature of the lens is concave. Are you clear? So D is called as, what is this? Already I have told the meaning of D is diopter, that is a unit of the lens. So power will be always negative in the case of concave lens. Don't forget. Understood? Now we are going to see when the power of the lens is said to be 1 diopter. Okay, what is 1 diopter, or when the power of the lens is said to be 1 diopter? Again, we will come back to the formula. What is the formula to calculate the power? Power of the lens is equal to 1 by f. Reciprocal of the focal length is called, what is this? Power of the lens. Are you clear? When this power will be equal to 1 diopter? That is a question. I'll tell you, if the focal length is 1 meter, if the focal length, either it may be a convex lens or concave lens, look at the value. The focal length value is 1 meter in the case of convex. In the case of concave also, the focal length is 1 meter. If the focal length of convex or concave lens is 1 meter, substitute here P is equal to 1 by 1 meter. 1 by 1. 1 by 1 is equal to 1, that is equal to 1 diopter. If it is in the form of convex lens, in the case of convex lens, the power value will be, power of convex lens will be plus 1 diopter. If it is in the form of concave lens, in the case of concave lens, the value of power of the lens will be minus 1 diopter. Let's calculate the power of the various lenses of various focal length. The focal length of the first lens is 15 centimeter. Focal length of the second lens is 10 centimeter. Focal length of the third convex lens is 5 centimeter. We know the formula P is equal to 1 by F. Here 15 centimeter is converted into 0.15 meter. Substitute the value in the formula. Finally, you will be getting the power value as 6.66 diopter. Since it is convex lens, we can write it as power is equal to plus 6.66 diopter. In the same manner, we are able to calculate the power of the 10 centimeter lens and 5 centimeter lens. The power of the 10 centimeter lens is P is equal to plus 10 diopter. Power of the lens of focal length 5 centimeter is plus 20 diopter. Here on the other side, we have calculated the power of the concave lens. All the three lenses, they are having the same focal length as convex lens. The only thing is the sign must be changed. Here in the case of concave lens, the power must be taken as negative. The conclusion is the focal length, if the focal length is less, the power of the lens will be more. That is, degree of convergence or divergence will be more in the case of lesser focal length lens. If the focal length is greater, means degree of convergence or divergence will be less, therefore will be less. So finally, the conclusion is power is inversely proportional to focal length. Power of the lens is inversely proportional to focal length. If focal length is more, power will be less. If focal length is less, power will be more.